everyone. Welcome to this demo lecture from Eazyfixit Academy. Today, in this demo lecture, first of all, let's take the lab tour and then we'll move on to the other things. So let's move to the lab first. So this is the entrance of Eazyfixit Academy. On my left, we have the founder of Apple, Mr. Steve Jobs, waiting for you guys. Next, on my right, is the branding of Eazyfixit, the parent company for Eazyfixit Academy. Now let's go in and check out everything that is in there. Come on. So first of all, let me give you a 360 view of what this lab looks like. So to give a brief overview of this lab, first of all, on my left, you will see it's a wall decorated with everything related to MacBooks. The first block shows the block diagrams and the power flow in Macs. Then, second, we have the almighty digital oscilloscope, the key to solving all of your MacBook problems. Without oscilloscope, diagnosis is quite difficult. Next, we have the A1466 motherboard view. It is one of the most simplest boards that Apple has designed. So it is very easy to diagnose these boards and also to solve the problems that are in place. It is one of the most famous, or what you can say, well-worked model of Apple. And in the end, we have the robotics section, which is a future venture of Eazyfixit. Now, moving on to my right, first, what we have is the symbols, which are very important to understand the semantics that you all are going to learn about. They are the symbols for all the basic components that go onto a motherboard or a logic board. Second, we move on to the protocols, that is the I2C interface, PCI interface. These are few of the protocols that are used in the Macs. There are many more than these. Moving forward, we have the power flow diagram, which is also called as the power management diagram. How the power flows in your Mac is explained here. Below that, we have the RF section, which shows how the voice is transmitted. And in the end, we have broken down how Face ID works. it shows all different components that go into the Face ID. And behind me, this is the master desk. Here the professor would stand and use these machines and this setup for himself. On my left, you can see there are 3 setups for 3 students. Similarly, on my right, there are 3 setups for 3 students. This is an air-conditioned cabin. We have kept the capacity of this lab as minimal as possible to provide one-on-one attention to everyone, because what we feel at Eazyfixit is one-on-one attention is very important to learn all the basics and in-depth knowledge of MacBooks and iPhones. If I could just guide you to the ceiling. On the ceiling, we have the Eazyfixit branding and a few of the different component designs. Next, moving on, we'll take a brief look at what the syllabus holds in, and after the syllabus explained, we'll move on to the tool setup as well as the introduction of the staff members and faculty members that are going to teach. So let's move and take a brief description of syllabus from Rafiq sir.
Let me brief you the theory syllabus. What are going to be covered in theory syllabus? What is resistor? What is diodes? What is MOSFETs? What is logic gates? What is NOR gate? What is AND gates? We are going to cover all those things. How to use multimeters, how to use DCPS, power supplies, how to use oscilloscopes. All those things are going to be covered in a basic theory syllabus. We are going to learn about the block diagrams, how they are being connected each others together, and we are going to understand how they are talking each others. In theory syllabus, we are going to learn how to read the semantics, how to understand the semantics through board view and through the semantics actually, and how to identify the parts, like when we are checking the PCBs actually, like if we need to check the display connectors, then we have to go to the semantics, and then we have to switch to the board views, like which pins is connected to which rails. Through we are going to identify and we are going to learn through like ZXW, Oxenzy. Without that, we can download the semantics from the internet and board view files, how to find them, how to download them through genuine sources. We are going to teach you all those things, from where to get which are the trusted sources actually, from where to get the semantics. These are a lot of things actually which we are going to cover in a theory syllabus. Like sometimes if you look into the ZXW tools actually, sometimes you don't find something actually, but on the internet if you search, there are a lot of things which are available. Sometimes it's paid, sometimes it's free. So we are going to explain you how to find out. Like sometimes if you don't have semantics actually, but there is a data sheet of the ICs, like, so you can understand through that as well actually. But if you don't know how to understand the data sheets, so you won't be able to fix the issues actually. So we are going to teach you how to understand the data sheets of the ICs and how to find them as well actually on the internet, and how to search them. So all those things we are going to teach you in that theory syllabus. We are going to teach you how to check the protocols like I2C, SPI, LPC, HDMI, PWM circuits, USB 2.0, USB 3.0, how they are working and which protocols are being used in that circuits. So we are going to explain you all those things. We are going to teach you through the oscilloscope how to measure a signal like I2C, SPI and all those protocols. We are going to teach you what is peak to peak RMS, what is overshoot, what is undershoot, what is bandwidth, what is duty cycles, what is Vmax, what is Vmin, what is RMS. We are going to cover everything from scratch to till ends. In the oscilloscopes, how to turn on the oscilloscopes, after turning on, which knobs are responsible for which functions. We are going to cover every single things like when you are turning on, then after turning on, you have to set a channels. While setting the channels, if you are measuring I2C, how much voltage you need to keep it actually for the cursor, and how much voltage you need to keep it, and slope edge, slope downs. We are going to teach you everything, which functions while testings you need to set. Power supply circuits. We are going to explain you about the power supply circuits like SMPS, LDOs, buck circuits, boost circuits, how they are working. Step down, step ups. We are going to explain in theory CPU, PCH, clock, DDR, display, backlight, keyboards, Wi-Fi, HDMI, USB and all those how they are working together. We are going to explain about the Intel CPU, Core i3, Core 2 Duo, Core i5, Core i7s, and even we are going to explain about the generations actually. What is the core, like when we are saying that Core i3 or Core i5, so how many cores are inside the CPU, and what is hyper threadings technology. We are going to explain you in depth all those things. We are going to explain you through block diagrams how phone is being turned on, how CPU is communicating with the Wi-Fi chip, with the NAND chip, with the power chip, how CPU is controlling through protocols, all those chips, how they are being turned on sequentially. We are going to learn step by steps through the flow diagrams, and it's going to be quite easy while learning through block diagrams. Like if we have block diagrams, when which power is being turned on and which one is responsible for that power on. So we are going to learn everything step by steps. We are going to learn about the standby power circuit. We are going to learn about standby circuits. So like when you connect a charger, you get a green lights, you get a orange lights, how it's being controlled, which chip is responsible for that. So we are going to learn in the theory syllabus like SMC chip, T2 chip and M1 chip, and there are a lot of things actually which they are communicating like power chip, charging chip, clock chips, RAM through CPU and SPI ROMs, all those things, how they are communicating. We are going to learn every single things in a very depth details. What is backlight circuits? We are going to learn about the backlight circuits, like how we are getting the backlight on the display. So when we press the power key, the display will gives a picture and the backlight as well actually. How these things are being controlled inside the circuits. We are going to learn all about that. We are going to learn what is buck circuit, what is boost circuits actually. So you know what is buck circuits? How the voltage is being reduced and current is being increased. And what is boost circuits? How the boost circuits works actually. The voltage is being increased and the current is being reduced in the boost circuits basically, and how it's working. So through the multimeters actually it's quite impossible to test actually. So we need an oscilloscope in order to test that circuits like buck circuit and the boost circuit as well actually. So we have to learn the oscilloscope actually. If we don't know how to use the oscilloscope, then we won't be able to test actually we can only use the multimeter in order to measure the voltage actually, that's it. But if there is no switching, then we cannot test it actually. Sometimes inductor is bad, but we cannot test that actually, whether it's switching or not. So if we have oscilloscopes, if we can test that parts actually, if it's switching, then we can understand easily actually what are being wrong in here. So these are things we are going to learn in theory. What is type C actually, and how it works, like in iPhones, in the newer models actually, as we know it. In MacBooks, there's USB type C. You can connect a charger, you can charge your MacBooks, and you can connect your USB cables, and you can transfer your data as well actually. But do you know how it works? So we are going to teach you actually how these USB ports are working. Like from the same USB ports actually, you are charging your MacBooks and you are doing the data transfer as well actually from the same ports. Like 20 volts you are when you connect your chargers, it gives 5 volts and then it goes on 20 volts actually. What are power rails are responsible for that actually? What are signals are responsible for that? So we are going to teach in depth, in details actually, how the boot sequence works actually when you connect chargers, how standby circuits turn on, and then how later things like T2 controls the USB and how SMC controls the USB. So these are the things are going to be covered in very depth details actually. We are going to learn about the iPhone CPU and interface actually, how they are workings like CPU, DDR, cameras, Face ID, fingerprint sensors, and all those things actually. And about the LCD as well actually, we are going to learn from the scratch, like how the display is being presented on the screens, how graphics are coming on the screens, how backlight circuits are working in the inside the display actually, and what is polarizers actually, and how touch is working actually. When we are pressing on the display panels actually, we can touch through a touch screen actually, how they are workings. We are going to learn about that. How RGB colors are workings, we are going to learn about that. How display is being how display is coming on, how image is coming on the display, how the display is being processed actually, we are going to learn about that actually. How when we connect on the logic boards, which are the protocols are responsible for the image, and which are the powers which are the power responsible for the image. So we are going to learn all those things actually in the schematics, and we can understand all those things in the theory syllabus. We are going to learn about the charging circuits. Like what is charging circuit? Basically, when you connect a charger, does your phone works on the battery? No. When you connect a charger, your phone works on the charger. It doesn't work on the battery basically. It's charge the battery, but it doesn't work on the battery. So we are going to learn all those circuits actually, how degrees is controlling when the phone is being turned on the battery, when the phone is on the charging modes, how degrees is acting actually. So we are going to learn in very details. We are going to learn about the power flow actually, how the block diagrams has been designed in iPhones, how chips are connected in iPhones. Like when we connect a battery, from the battery power goes to degrees, and from the degrees power goes to the PMU, and then from the PMU power goes to the base, and from the PMU power goes to the CPU, and from the CPU it's control various signals, and then it's turn on the various chips step by step. So all those things we are going to learn in the theory syllabus, and we have designed very perfectly for that actually, so you can understand easily all those things. We are going to learn about network sections actually, how network section works, how network is coming in your device actually, how RX path is working, how network is coming in your device actually through your antenna, from the antenna to the antenna switch, and from that to LNA, and from LNA to transceiver, and from the transceiver it's modulate the signals and it goes to the baseband processor, and from baseband processor it goes to the CPU, and from the CPU it goes to the audio codec, and then audio codec send a signal to the speakers into audio forms, and then we get the voice from that actually. That's the end of the theory syllabus. Let's move to the practical syllabus. Introduction of logic boards like MacBook Air, MacBook Pro, iMac. So we are going to learn each and every components, how it's being placed on the logic boards and what are the functions of them. So that will be the introduction of the logic boards, like from 2010 to 2021. So there are various logic boards we are going to understand actually. So on which logic board which part are being installed, like SMC, T2, M1 chips, and on which logic boards there is a HDD, there is a SSD, which are removable, which are not removables. We are going to learn, and in which MacBooks there is a MagSafe chargers, and in which MacBooks there is a USB Type-C chargers. So all those things we are going to learn. Introduction of logic board. All those things we are going to learn in the practical ways. What is power supply circuit? As I have explained you in a theory parts actually. So we are going to learn about in practical parts as well actually how they are working. We can analyze through oscilloscopes actually, and we can see it into real times actually. So we are going to learn in a practical parts. We are going to probe on the logic boards and how they are working. We are going to test all the power supply circuits and the signals on the oscilloscopes. One of the most important things actually, as we can't test on the multimeters, that is called clock. So if you don't have oscilloscope, if you don't know how to use the oscilloscope actually, so we cannot test the clock signals actually. So that is most important part actually. We are going to learn in a practical way, not only in a theory, like this is a clock and how it works. We are going to learn in a real times actually how they are working. We are going to learn how PCH, CPU, SMC, RAM and NAND, they are communicating each others, and what are the functions of them, what are the power rails for them, on which power rails they are working, on which voltages they are working, what are the protocols are being used for them. Like on the NANDs there is a PCI, on the SPI ROMs there is a SPI. So all those things actually we are going to learn step by steps. Like for SPI they are using SPI protocols, like for the NAND they are using PCI. So all those things, like for the display they are using MIPI. So all those things we are going to learn. SMC chip, basically what is SMC? When you connect a charger, how you are getting a green light, how you are getting an orange light. So all those things actually, how a standby power circuits comes actually. So all those things are going to be covered step by steps. What is standby power? What is boot sequence? What is T2 chip? What is SMC? What is M1 processor? And how it works actually. We are going to learn everything in a practical ways. What is HDD? What is SSD? What is flash drive? What is NAND? What is PCI? This is all we are going to learn. If we look into the older MacBooks, in the older MacBooks only there was HDD, there was SSD, but there was no flash drive. If we look into the newer MacBooks, like in MacBook Air, there was a flash drive that was removable, that was replaceable. But if we look into the newer MacBooks, like which are having T2 chips, in that chips actually, in that models actually, there is a NAND, there is a PCI. They are being installed on the logic board. So in order to replace them actually, we must have a good hand skills, and we must have a good knowledge how they are working actually, how to replace them, how to program them. All those things we are going to learn, and the practical parts, how to remove the NAND chip, how to reinstall the NAND chip, all those things is going to be included in the practical parts. On the older MacBooks, it's quite easy to upgrade the SSD, but on the newer MacBooks, it's quite hard to upgrade actually. When it comes to the logic boards, when it comes to the logic boards, the parts are being installed on the logic boards like NAND and the PCI. So you must have a good hand skill, you must have a good knowledge in order to understand, in order to replace those chips actually. So we are going to teach you in a safe manners how to remove that IC and how to clean the underfill glues, the black pasted glue, the white pasted glue, how to clean them safely and how to install it back after programming all those chips, and how they are working through sequentially. And if you are taking, like, you know, there are 4 NANDs. If you are taking like one of the NANDs actually, so from where to get from where to get that NANDs, and from where to get that NANDs and how to install them. So these are the sequence actually which we are going to explain you. When it comes to RAM, as we know it actually, in the older MacBooks, like we can upgrade the RAM easily, it's a plug and play. But when it comes to new MacBooks actually, they are being installed on the logic boards, and you can't just take a bigger size RAM actually and install on the logic board. There are more things need to be done actually. There are strapping register which we need to configure actually. So all those things actually we are going to learn how to upgrade the RAMs which are being installed on the logic boards. When it comes to the software upgrades in the older MacBooks, it's quite easy actually. We can just make a bootable USB PD and then we can install the OS. But in the newer MacBooks actually, it's a similar to an iPhone actually. There's a different softwares. Through that softwares actually we can upgrade the softwares actually, and we can restore the bridge OS as well actually when it comes to the T2 chip actually. But when it comes to the M1 chip actually, we only have that options actually in order to install the softwares actually. Like if we want to upgrade or if we want to reinstall the softwares, we have to use that softwares. We are going to introduce you all those things in this syllabus actually. When it comes to flex gates, it's a very quite common issue actually. So when you tilt your display actually on the 45-degree angles, sometimes you get a screen, sometimes you don't get a screen, sometimes there's a stage light effect as well. So when there's a stage light effect, it means there is a flex gate issue. So we have to fix the flex gate issue. We can fix that through jumper wire, and we can fix through flex cable as well. So these are the two methods actually, but we are only recommending the through flex cables, through jumpers. It's not recommendable, but in a very urgent cases, or if we need to do the data recovery or some things, then we can use that method as well actually, but it's not recommended. So we are going to teach you how to fix a flex gate issue through flex cable. So that is quite common issue. We are going to learn about the charger as well actually. What is MagSafe and what is the USB Type-C actually. So USB Type-C is different, and USB and MagSafe is a different actually. MagSafe, it's not a smart charger basically. It has ID pins, but it's not a smart charger, same like iPhones, same like USB Type-C. When you connect a charger, you will get only 5 volts, and after communicating to the logic boards, you will it will boost to 20 volts actually. So that is called smart chargers. So all those things we are going to learn in depth actually, how they are working and how they are communicating through CD3215 actually. That is the chip actually which is responsible actually for USB. So that is called MUX chip, USB MUX chip basically. So all those chips are working together actually when it comes to 2 ports or when it comes to 4 ports actually. These are the chips actually which they are working together. And when it comes to like Type-C actually, when your MacBook is not booting up, it's only stuck on the 5 volts actually. But you are not able to figure out what is wrong with your MacBook. So there are various methods actually. We are going to teach you that as well, how to identify which port is not working and which CD3215 is not good and which CD3215 is malfunctioning and why your MacBook is dead, why it's not turning on, what are the reasons actually. So you're going to learn everything step by steps about the USB Type-C. How a smart battery and how a smart charger works, we are going to learn that as well actually in some MacBooks actually. So as we know it in the older one. So in the older one there was no smart battery and there was no smart chargers basically. So but in the newer one, that is called Type-C, and there is a smart battery. When you disconnect a battery, after disconnecting when you reconnect a battery, you try to turn on, your MacBook is not going to turn on. Basically that is called a smart battery. So how they are being controlled, how they are working, we are going to learn everything in that. As we know it actually, when it comes to touch bar, when it comes to touch ID, in the older one there was no touch ID, no touch bar, but in the newer one there is a touch bar, there is a touch ID. How these circuits are working, how we have to fix it, what are the common errors, we are going to learn all those things actually. When it comes to trackpad actually, there's taptic engine in the newer trackpads, but when it goes to the older one, there is a mechanical trackpad actually. When we was used to press on the trackpad, we was used to hear the sounds, that was the mechanical sounds, but now there is a taptic engine. When we are pressing on it, the sound is coming from the taptic engine, it's not coming from the mechanical buttons basically, because there is no mechanical buttons, it's been replaced into taptic engines. When it comes to camera actually, how camera works, we are going to learn in very depth actually. How many DDRs do you need for the camera actually, and how the camera has been designed from the scratch to ends, we are going to learn in the practical way and in a theory way as well actually, how they are working together. When it comes to Wi-Fi actually, as we know it in iPhone actually, that is common issues, but in a MacBook as well it's common issue. But in the older one it's a plug and play, but in the new one it's not plug and play actually. So in the new one they are being installed on the logic board, but when it comes to replacement, it's not like iPhone, just remove it and reinstall and untie. But there is many more things actually which need to be done. We are going to learn all those things in the practical way as well. When it comes to iPhone NAND, like we have to upgrade the NANDs, or there is error codes like error 9 4013, error 6 4014. So in that case, how do we need to fix it actually, which are the programmers do we need to use it, and how we are going to use it actually. All those things are going to be included in the practical way and in a theory way as well actually. So we are going to learn all those things actually, how to fix error 9, how to fix error 9, how to fix error 4013, how to fix error 6, etc. and all those things actually. According to OS, the codes are being changed, error 7, error 56 as well actually. There are so many errors occurs according to the operating systems actually. It may change in the future as well actually, so we don't need to remember the names only, that's it. We need to understand the sequence, when and which error comes and what are the reasons actually to occur the errors. We have to understand about the logs reports actually. So we are going to learn about the logs reports actually, what our logs is saying, what are the common errors which are generating in the logs. So we are going to understand all those things in a practical ways. When it comes to logic EEPROM or BB EEPROM, they are a bit different. Logic EEPROM till iPhone X, it's replaceable, we can replace it, but baby EEPROM, it's not replaceable. So we cannot replace it. We can read that baby EEPROM and we can write into the different motherboards actually, if when it comes to the swap. All those things we are going to learn in very details, like when we are doing board swappings, what are the chips which we need to transfer, all those things, what are the chips which we need to transfer. We are going to learn all those things in details, like CPU, NAND, basebands, BB EEPROM, logic EEPROMs, whether we need to swap it or whether we need to read it. Actually, we are going to learn all those things in very depth details. What is SPI-ROM? When it comes to SPI-ROMs, we can say SPI-ROM is a bootloader. So if there is a no bootloader, there will be no screen, and there will be the machine is not going to boot basically. But in the older one, it's quite easy. But in the newer one, it's a bit difficult actually to program it. But we are going to cover all those things like T2 chip, M1 chips, and the older one, like which include the SMC. So all those things is going to be covered in a practical ways, how to program all those things. When it comes to Face ID, we need to understand the logical functions, like what are the relations in between like infrared cameras and dot projectors and flood illuminators and distance sensors. So we need to understand every single things actually in order to repair the Face ID. Then our problems is going to be fixed fastly if we understand the logical reasons. All those things are going to be covered in a theory and in a practical ways as well actually. When it comes to the CPU actually, we are going to learn from A82 till A13, A14s, all those actually we are going to cover, and what are the difference actually in betweens and how to handle them in a safe manners way without breaking the pads. So we are going to learn everything in a very detailed ways. When it comes to the sandwich board actually, many times sandwich board are damaged, or sandwich boards are little bit bad actually. We are not able to install it properly actually. There are various tools actually which we are going to introduce you in the practical ways, how to use them and how to install them safely and perfectly. That was it from my side. Now let's move to Karan.
So we got a brief description about the syllabus. Now let's take a look at what tools you're going to get to work with. So let's move on to the tool section. Different kinds of uses, and we'll show you all of those, how to use it in different ways. Moving on, this is a JCID. It is also a multi-purpose tool. It can be used for programming from Face ID to ear flex on X and higher devices. Next, we have the JCB box. We use it for purple mode flashing and writing SN numbers. This is a lattice programmer. It is used to program lattice BGA. Next we have is the IP box. It is used for reading NANDs. This is the WL NAND reader. It is also used to know what kind of NAND it is. It is used up to 7+, and for the higher models we use these boxes. These are JC boxes for reading NANDs. Moving on, this is the DC power supply that we are going to use in our daily functions. This is the hot air station, and this is the second hot air station. We have two hot air stations on each deck purposely. We are going to show you how to use which hot air station and when to use it. Next, moving on, this is the microscope that we are going to be using. So we'll show you how to adjust it, and after adjusting it, how to make use of it. Moving on, this is a fume extractor by 2ULL. It is used in this lab to keep the fumes out, because this being an air conditioned lab, it is packed from everywhere. Next, we have the magnetic stencils. This is a preheater. It is used for sandwich board separation. If you have watched a sandwich board separation video, you must already be knowing the use of this. Moving on, this is a magnetic stencil. It is used for CPU reballing. And next to this, in this pink box, we have different kind of knives for cutting the glues which come on the CPU. I would like to show you how it works.
how it looks. As you can see, these are the 3 handles that come with it, and these are different kinds of blade. This is a very expensive set, and you need a lot of practice and skill to use this without breaking the blades. Moving on, these are the non-magnetic stencils. The first one are for the iPhone, and these ones are for the Mac. Moving on, we have some basic tools which include the brush that we would use for PCB cleaning and for CPU cleaning. And these are the few tweezers that we are going to use, which include tweezers from BR as well as 2ULL. These are one of the best tweezers that are available in the market. Next, we have the solder paste. We'll use this for CPU reballing as well as reballing other ICs. We are using this Fluke multimeter. So again, this is one of the best multimeters which is out there. So for our use, we are using this. Next, we have this stand which is used for repairing the Face ID. This is the PCB stand that you will use for holding your PCBs in one place when you are heating it or when you are soldering it. Next, we are moving on to the almighty oscilloscope. This oscilloscope is the reason we could master so much in the MacBook. It helps us diagnose each and every problem that comes in our way. Moving on, we have these stencils, or you can say holders, for PCB of 11 and higher devices, which are used again for working with sandwich boards. This is a T2LX soldering station that we'll use while working here. Next to this is a dock flex tester. It is kind of a magical device that will let you know, or will in fact teach you how to use it when you attend the lecture. Next, we have this is a Face ID repair kit which you are looking at right at 2. Moving on, this is the UV mask on the right, and on the left is the Face ID repair kit number 2. This is a desoldering wire wick which we'll use to clean the older solders that were present on the board. So these are few of the many tools that we would be using in our work at Eazyfixit Academy. So for knowing more about these tools, you can contact us, and to learn about the rest remaining tools, which due to being business secrets we cannot share here on the video. So please attend the lectures to get full information about these. So that was it from the tool explanation or the tool overview. Let's move on to the next section. Now let's move on to the staff introduction. I would give you a brief introduction about each of our staff members and what they would teach you. So first in this list is Mr. Rafiq. He is an expert of Apple products. He has worked on chip level repairing and level 4 troubleshooting for about 14 to 15 years. He has had a work experience in Netherlands as well as China. He is a well expert in this Apple field, or you can say the repair fields. Moving on, we have Mr. Hemant. He is a master degree holder in electronics. He is an expert in product designing. He has designed different types of boards for TVs, laptops, cameras, mobile phones, and has experience of working in different multinational companies which belong to USA and UK. Next on the list is Mr. Srikanth. He is a master's degree holder in political science. He is an Apple certified professional and has worked with Apple for around 6 to 7 years. He has had experience in different fields like sales, management, training, etc. He would take care of personality development here at Eazyfixit. Next on the list is Miss Chetna. She is a bachelor's degree holder in computer science. She is a software programming expert and also has good experience in video editing as well as graphic designing. Moving on, Karan, that is me. I am a bachelor's degree holder in mechanical engineering. I am associated with Eazyfixit for last 4 years and I expertise in fields like software programming as well as CAD designing. Next on the list is Mr. Rahman. Like Mr. Rafiq, he is also an expert of chip level and level 4 troubleshooting. He has worked in Gulf countries for around 14 years and will take care of the practical department alongside Mr. Rafiq. So this was a short overview of what a team looks like here at Eazyfixit.
So guys, that was it from our side. Thank you for watching the video till the end. For more details, take a look at the description box or the brochure which is linked, and to get more information about the courses, please give us a call on the below mentioned number. And thank you for watching the video till the end. Stay happy, keep learning.